All right, so arithmetic and geometric sequences. We talked a bit about this in 10-2, where an arithmetic sequence is one where it has a common difference between each term in the sequence. Geometric was a common ratio, so we would be dividing the second number times the first by the first number, and so on to find that out. Okay, so what we're going to look at or what we did in 10-2 was you had to figure out, well, what's going on here? How am I getting that pattern, right? I'm going to tell you how you're going to get that pattern, or at least how you can find that the term that you're missing, okay? And that's with this formula right here, okay? Whatever term you're looking for, you can find it by taking the first number, adding the difference, which is being multiplied by whatever number in the sequence you are, minus 1, okay? So just a reminder, this is our first term in the sequence. And this is our difference. Okay, so if we were going to find the common difference and the formula for the nth term of the following arithmetic sequence, first thing we do for the difference is we subtract. So you take the second term and then subtract the term before it. Okay. Now I could have picked negative 13 and negative 8. I can do any one I want to. But since they already told me it's arithmetic, right, you just need to take a term and then the one before it, and that's your subtraction. Okay, so that's going to be negative 5. So D is negative 5. Then we know our little formula up here, we have A sub n, A sub 1 is 2, plus the difference, so that's going to be our negative 5, times n minus 1. Now, you can leave it that way, but generally when you're writing a formula like that, you would simplify. So when this one simplifies, you get 7 minus 5n. So my answer is A sub n equals 7 minus 5n. And then the common difference. Those were the two things they asked me to find. All right, so find the 36th term of that sequence. Okay. Now, they did not tell me that this one is arithmetic. So before I start doing anything, I better figure out, is it really arithmetic? It's on the side that's arithmetic. You would think that it would be arithmetic, but, you know, on your worksheet, they're all mixed together. So you need to take a moment and figure it out. So if we go back this way, that's minus 6, right? Minus 6, minus 6. So it is arithmetic. We have a common difference. So D is negative 6. And then if we do our formula, it would be A sub n equals A1, which is 10, plus negative 6 times n minus 1. Okay? So if we put in, we want the 36th term, so this would be A sub 36 equals 10 plus negative 6 times 36 minus 1. Okay. And when you do that out, you get negative 200. Sure beats counting out to the 36th term, does it not? Okay. All right. And then given that A sub 4 is 20 and A sub 13 is 65, find A sub 20. All right. So a couple of little problems there with our formula, right? There's no A sub 1 here. There's no D. And we don't have consecutive terms to find D, right? Okay, so then what can we do? Well, we know that if we use our basic formula, we know that A sub 4, right, is equal to A sub 1 plus D times 4 minus 1. And that is equal to 20. And A sub 13 is equal to a sub 1 plus d times 13 minus 1, and that is equal to 65. Does that make sense? Okay. So once we know that, we've got two equations there with two variables, and so now we use some really old math that we used in Algebra 1, and we solve this system. Okay. Before I'm going to solve it, I'm going to clean this up a little bit. This would be a sub 1 plus 3d equals 20, and this would be a sub 1 plus 12d equals 65. All right. So when we have a setup like this for systems, one of the ways we solved, we used matrices, but a lot of my students did, at least earlier in the day, didn't remember matrices at all. But the other thing we did was elimination, and we did a lot of elimination. So I'm going to use that method to solve the system. Some of the other things we did for solving systems was you could graph the two systems and see where they intersected, and you could also do substitution, where you solve for one variable and substitute in for the other one. Okay, so all of those methods for solving still work. I'm just going to use elimination up here because it's the one I'm picking. Okay, all right, so in order to eliminate, you have to have opposite signs. So what I want to do here is I want to multiply this whole thing by -1. And when I do that, I get negative a sub 1 minus 3d equals negative 20. Everybody cool with that? All right, so then we add the two equations together, and this goes to 0. We get 9d equals 45, which means d equals 5. So we were able to now have the difference, right? Okay, we still need a 1, so we go back to one of our two equations, it doesn't matter which one, and we substitute. So I'm going to use this one, a sub 1 plus 3 times 5 equals 20, which means a sub 1 plus 15 equals 20, which means a sub 1 equals 5. Now, I do want to point out that they're the same number in this problem. That is not the usual thing to happen. You don't usually have your difference and your a sub 1 be the same thing, so that's just a coinky-dink. Don't put any stock in that, okay? You might make yourself a little note, won't always be the same number, okay? Because a lot. So then when we put it together, we're looking for a sub 20, right? Well, a sub n, we now know is going to be 5 plus 5 times n minus 1. So at a sub 20, that's going to be 5 plus 5 times 20 minus 1. Which equals 100. Okay, so an arithmetic means just is two numbers or two given terms of an arithmetic sequence are called arithmetic means. Okay, so any two numbers in the sequence. It doesn't have to be consecutive numbers, it just has to be two numbers. Okay? So they say insert 3 arithmetic means between 9 and 29. So we're going to start here at 9. We're going to insert 3 terms between them. Okay, so these are my two given terms, 9 and 29, and we're putting 3 arithmetic means because they're that means the 3 terms between them. Okay. All right, so we're looking there. Now this time we at least know what a sub 1 is, right? But we don't know what d is because we don't have two consecutive terms. So we do know that a sub 1 is 9. And we still have our formula. And if we're looking, what would this would be our 5th term, would it not? Right? So we know that a sub 5 is equal to 29, which is equal to a sub 1, which is 9, plus d, times 5 minus 1. Okay, all right, so cleaning that up a little bit, right, this would be 29 equals 9 plus 40, which means 20 equals 4D, which means D equals 5. So since D is 5, we know that we're adding 5 each time here. So that would be 14, then 19, then 24, and then 29. Okay. So we inserted our 3 arithmetic means between 9 and 29.